Alright, so like I said, guys, we've done lots of different probabilities. On the test, we're not going to tell you which type of probability is which, what you need to do for each problem. You're going to have to figure it out yourself, right? Like what type of probability is, what things we need to do. The next one we're going to talk about is binomial probability. So bi means two, right? Like a bicycle. So this is things with two results. There's only two results happening here. It's like tossing a coin, throwing a die. Do we get a 4 or not a 4? Right? There's only two possible outcomes. So, in binomial probability, there are repeated situations called trials. Right? So there's multiple things happening. There are a fixed number of trials. So we're saying we're flipping a coin 10 times. So there will be 10 different trials. Right? So there's a fixed number. They'll never be like, we're going to flip a coin for a day. They're going to tell you specifically how many trials you're going to have. Okay? For each trial, there are only two possible outcomes, often called success and failure. So that could be like, if we're talking about flipping a heads, then heads would be our success, tails would be our failure. There's only two outcomes, success or failure. And the probability of success is the same in each trial. So, like when I roll a die, the odds don't change. It's always 1/6 chance that I roll what I want to roll. The odds should never change from roll to roll or from trial to trial. Each trial is an independent event, so they're not hinging on each other. What happened in the first trial doesn't affect what happens in the 8th trial. Alright? Everything's an independent event. Make sense?
Yeah.
Okay? Okay. So example 1. Let's toss a coin. Toss a fair coin 3 times. What is the chance of getting 2 heads? Okay. So our outcome result of 3 coin tosses, the event, we want 2 out of 3. So let's list out what are all the options we could get. Is that listed here? What are all the options we could get? When I flip 3 coins, what could I end up getting?
Heads, tails, tails.
Okay, so let's list those out. Heads, heads, heads. Tails, tails, tails. See, mine already listed for me. It's really nice. But there's 8 different outcomes you could get, right? You get 2 different outcomes for each flip. So 2 times 2 times 2. I can get all 3 heads. I get 2 heads and a tail. Heads, tails, heads. Tails, heads, heads. Heads, tails, tails. Tails, heads, tails. Tails, tails, heads. And then all 3 tails. There's 8 different possibilities for me to get when I flip a coin 3 times. Right? That was pretty easy to figure out. So based off that, based off my 8 outcomes, in how many of them do I get 2 heads? And when I say 2 heads, I want exactly 2 heads. I don't want more than, less than. I want exactly 2 heads. How many out of my 8? There's 3, right? 1, 2, 3. Okay? So if I looked at that, what would be the probability of getting 2 heads? 3 out of 8. So my probability for getting 2 heads when I flip a coin 3 times is 3 out of 8. It's not too bad, right? Do you have any questions so far? It'll all come full circle in a second, I promise. Okay? Alright. So, then let's calculate all the possible outcomes. Well, getting all 3 heads, 1 out of 8. 2 heads is 3 out of 8. 1 head, 3 out of 8. No heads, 1 out of 8. Right? So those are 4 probabilities. Those are 4 options you can get. 1 8, 3 8, 3 8, 1 8. Now, we can write this in terms of random variable x. We're not going to do this. You're never going to see this. All right? We're never going to write it as probability, random probability of x equaling 3 is 1/8, things like that. You're not going to see that on the test. All right? The big part here is being able to calculate all of our possible outcomes. Okay? We good?
Yep.
We all have all of our possible outcomes written down and our probabilities for all those outcomes written down. 3 heads is 1/8.
Oh.
We all have that written down?
Yeah.
Where it says probability of 3 heads, probability of 2 heads, probability of 1 head. Right? You don't need to write down heads, 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 tails, things like that. Get the probabilities written down. Right? 1/8, 3/8, 3/8. We showed it just by looking at our diagram, writing out those heads, heads, and tails. Okay?
Wait, why are there like 3 heads multiplied, but
Because this is taking the probability of getting heads on all 3 of them. Each one is 1/2, so I multiply them.
but why is it 1/8 plus 1/8?
Because this is the probability of getting a heads here is 1/8, 1/8, 1/8. Probability of this happening, of heads, heads, tails, is 1/8, right? That only happens once. This happening is once. That happening is once. Because you can get any of these 3, and it would satisfy 2 heads.
Okay.
So you would add those 3 probabilities together. Okay? Does that make sense?
Yeah.
We all good so far? Alright, what if we told you we wanted to roll a fair die? Right, we want to throw it 4 times. We want to calculate the probability of getting exactly 2 5s. Well, if you look, our sample space, and I can get 6 different outcomes for all 4 rolls. That means there's 1,296 total outcomes. Do you want to sit and list out 1,296 total outcomes and then figure out how many have exactly 2 5s?
Let's do it.
No, we're not going to do it.
Alright.
Right? We're going to have a formula. The formula for binomial probability is probably the hardest thing that we're going to do for today.
Can we get it on the test?
You will not get on the test. That's the hardest part. It's just remembering it. But honestly, it's really not that hard to remember.
Song?
Alright? No, there's no song.
Oh, there's
Alright? So, it's really not that bad. So what happens? It looks like a lot. Trust me, it's not that bad. It looks like a lot, but just trust me. So, it's a combination of n things taken r times, right? We've done that part before. You've done that. Times p of s. That means the probability of success, or the probability of what you want to happen. So say it's flipping your heads. The probability of flipping your heads would go right here, and it'd be raised to the r power. Well, r is the number of times we want that thing to happen. So probability of success raised to the power of how many times we want it to happen, times the probability of failure. So in the case of flipping a coin, it'd be the probability of flipping it tails. To the n minus r power, how many times we want it to fail. Right? Now the one thing I'd say to be really careful with, success isn't always a good thing when we're doing binomial probability. Alright? So success is just getting the outcome we desire. It doesn't mean a good thing happening. Does that make sense? So like failing, if we talk about ever like doing tests, like how many students fail the test? They have this probability. Your probability of success might actually be the probability of them failing the test. But it's the desired outcome we want. Okay? So we gotta be really careful when we're setting up problems. Like I said, we do not get this formula on the test. So you gotta know it. But it's really not that bad. Okay? Do you have any questions? Or should we try some problems? Okay, let's try some problems. So we're talking about a die being thrown 4 times again. Same thing as that example. Throw a die 4 times. We want to calculate the probability of exactly 2 5s. Okay. How many trials do we have? How many times are we rolling a die? 4. So that is my n value. Okay? My r, and if I was you, I don't know, do they have a spot on there for you to write it out? N equals, oh perfect, look at that. So n equals 4. My r, the specific events we wish to obtain. Well, we wish to obtain rolling a 5. How many times do we want to do that? Twice. So my r is 2. What is the probability of success, or the probability that I roll a 5? 1/6, right? It's one number out of 6 on the die. So 1/6. And then what is the probability of failure, or that it will not occur? 5/6, right? There's 5 other numbers out of the 6 on the die. So I have all the information I need now to put it into my formula. So I have 4 events. And I'm choosing 2, right? It's a combination. It's always a combination. Never will this be a permutation. It's always combination. Okay? So 4C2 times, we said the probability of success to the r power. Well, the probability of success is 1/6, and I want it to happen 2 times. So it's to the second power. Times the probability of failure to the n minus r power. Or how many times are we going to want it to fail? Well, n minus r will be 4 minus 2. which means it's to the second power. So 2 times we want a heads, 2 times we want not a heads. Does that make sense?
Yeah.
Okay? I'm going to change this to 2, just kind of like doing, there we go. Okay? So then you can punch this all into your calculator at once. Right? We just got to be careful using parentheses. So if I was to do it with my calculator, I'd go math, probability, NCR to start with, 4, 2, right? Then I would hit times, parenthesis, 1 divided by 6, parenthesis, to the second power, times 5 divided by 6, to the second power. And I hit enter, and that's the probability I'm going to roll 2 5s, exactly 2 5s. Now that's given to me as a decimal, which should we probably write our answer as a decimal?
Sorry about 100.
No, we do percents a lot of times, right? So it's multiplied by 100. So Q, rounded to the nearest 10th,
10,
10th, what's my probability of rolling 2 5s?
11.6%.
11.6%. So that's way easier than writing out all of our outcomes we could possibly get and trying to figure out how many of them have 2 heads, or 2 5s. Alright, now this is only for problems that have exactly in them. Right? Exactly 2. Exactly 4 heads. Exactly 3 heads. Whatever it was. Tomorrow we're going to talk about what would happen if it said 2 or more 5s. Or 2 or less 5s. We'll talk about that tomorrow. Today we're just doing exactly. Okay? Do we have any questions so far? You guys all look dead.
It's a Monday.
It's a Monday. It's a Monday. Alright. Good news is we only have like
1 problem.
2 more problems.
2.
2 problems to do. Alright, example 3. Rolling a die 100 times. What's the probability of rolling a 4 exactly 25 times? How many trials do I have? What's my n value?
100.
100. Right, I'm doing it 100 times. Okay? R, how many times do I want my desired outcome to happen? 25, right? I want a 4, but I want it 25 times. So my R is 25. Now, probability of success. Well, success is determined by rolling a 4 right now. So what's the probability that I roll a 4? 1/6. Probability of failure, I don't roll a 4.
5,
5/6. Alright, let's just use our formula. 100, C, 25, combination, right? 100 times, want to pick 25 times. Times the probability of success to the R power, or how many times I want to succeed. I want to roll a 4 25 times. Times the probability of failure, or rolling something besides a 4. How many times should I roll something besides a 4? 75, right? N minus R power. I should fail 75 times so that I succeed 25. Does that make sense?
Mm-hmm.
Do I need to write out 100 minus 25 up here, or are we all good? We're good? Okay. So punch it in your calculators. Do you want me to punch in mine, or are you guys going to be good?
1%.
What? Approximately 1.0%?
Yep.
It's not 1.2 here.
The round.
Well, you have to round, yeah.
Did we all get that?
Yep.
Did we all get that answer?
Mm-hmm.
Do we have any questions? None so far? Alright. The next one's a little trickier. I want you guys to try it on your own. Alright? I'll give you guys a couple seconds, try it on your own. If you're stuck, if you have a question, raise your hand. Work with someone next to you. Right? Get through it. Problem solve. You're smart people. Try it on your own. I'll give you a couple minutes. We'll go through it. See what we do. There should be some boxes on the second shelf back there if you want to grab one, open it up.
Mr. Reed?
Yep.
What would you get for your nationality?
1 second. What did you get? So probability of success. Yeah. So we want to be stopped at a red light, right? So that's like our success.
Okay.
Okay, so how long is the red light? About 50. Did you write up your opinion? That way I know that you did it and you just copied somebody else's.
You can give me another one. You want the other one versus two.
I'm not saying you're not gonna get perfect. I was saying that you should show some work, like writing the equation out, so I know you know how to do it and you're not copying it.
I didn't figure out it. Yeah, I didn't do it. I don't know what I'm doing.
How many cars do you want? 8, right? So that's our plan. 80 cars. Okay. So how many do we want to stop at a red light?
You want to read?
So that's our automatic.
How do you guys go?
What?
Oh.
How do you go?
I wouldn't say 1/8, but like, what's our success? What do we want to happen? We're gonna stop at a red light, right? How long is the light red?
No.
Out of how many total seconds? It was like 50, so our success is 15 out of 50.
Okay, I did that. That's what I thought.
And then our failure then is 35.
I literally
Good.
had all of this in my question, but then
Just write it down.
no, because I don't like to be wrong.
Transfer it. Well, it's a good thing you have an eraser then, just in
No, I
case.
didn't get this worse.
All right,
Yeah.
how do we do? Do we think we did pretty well? Or do we need more time?
We're good.
We're good? So if I pick on random people, they'll be able to answer?
Yeah.
Yeah? Alright, so at a certain intersection, the light for eastbound traffic is red for 15 seconds, yellow for 5 seconds, and green for 30 seconds. Find the probability that out of the next 8 eastbound cars that arrive randomly at the light, exactly 3 will be stopped by red light. Now before we even do the problem, I would highly suggest on all the problems on the homework and things like that, write these 4 things out. Right? Make sure you know what each piece is before you start trying to put it into a formula. That's my suggestion to you. Now, do you have to listen to me?
No.
No. Is it highly suggested you listen to me?
Yes.
Probably. Next I know what I'm talking about, hopefully.
Probability.
Alright, so N. How many trials do I have here? How many cars are going through there? 8, right? There's 8, the next 8 eastbound cars. Okay? R. How many do I want to succeed or to do something? 3, right? I want 3 to be stopped by a red light. Which means being stopped by a red light is technically my success here. So the probability of success, it is red for 15 seconds out of how many total seconds, Q?
50.
50. So 15 out of 50. If you want to reduce it, you're more than welcome to. Which means my probability of failure then is 35 out of 50. It being at a yellow or a green light. So now all I gotta do is plug it into my equation. 8C3 times probability of success. 15 out of 50 to the power. I want 3 to be successful. So to the power of 3 times probability of failure. I want 5 to not be stopped at a red light. So it's N minus R is 5. And then I punch out my calculator. Paige, what do you get?
25.4.
25.4%. Okay? Any questions, guys? So you got to read the problems carefully. All right.